Alright, this video we're going to look at the dungeon generator, of which you can find the files, how it looks, why it works, and basically what I was inspired by. So I took a look at the Caverns of Arne, which is a level in Diablo. I thought this was interesting because it has these sort of interesting contours, and it's an interesting looking environment, and I thought that would be an interesting dungeon generator to build. You could also do dungeon generators for more static environments, but I found I've already covered those in past tutorials and how I would do them. So I thought I'd build a quick file to show you how to do this. So when you open the file, the first thing you get is this. It's going to take a little bit to compute, maybe a minute or so, but this is the result. Now, this entire result is calculated from a very simple input. In fact, there's two inputs. There's the terrain inputs, which is this, and you can see this basically corresponds to the terrain that we get in the end. And there is the input for the bridges, and bridge input is literally just a simple curve, just like that. So we can play around with this. So you can select this curve right here, and you can, for example, view the terrain maybe at the same time. And what we can do is we can actually move this guy around, and you can see this just recomputes, and we can move this bridge from anywhere to anywhere. We can make it super long, right, or we can make it pretty short. And on the other hand, we can do the same thing with the terrain. We can change this terrain in any way. We could actually make this, disable entire sections of the terrain. We can add sections of the terrain, whatever we want. So, for example, if we wanted to change this section right here, what we could do is we could just move this section to be a little bit farther out to the right. Let's say gameplay has decided we want to move this a little bit farther over. I'm just going to switch to manual mode, by the way, so it's not going to recook as often. So I'm going to move this over a little bit, just like that. So I've moved our island. Let's make it a bit more of an exciting change, and perhaps we get rid of this section right here. And so we can already see how our terrain is going to look. We can see what we're going to get rid of. So if we remove this section, for example, we're going to get this as our terrain. Now we also know that our bridge is now no longer going to fit, so I'm just going to update our bridge to go between this point and this point, for example. Now, what we can do is we can just go to the very bottom. We're going to click this merge node, which gets all the data together, and Houdini is going to do a lot of calculating. You can see the calculating in the bottom right here, and we're basically building an entirely new world from this. This is going to take, I don't know, maybe a minute if you're doing the full scene. I just deleted a couple things so it's a little bit faster. But here you go. This is the new world. I clearly did a bad job of placing our wonderful our friend the there we go. I didn't do the best job of placing this guy, so I'm just going to move this over. But again, the cool thing is we don't really have to worry about these changes too much. We can just move this around pretty much whenever we want to. Alright, and we've got our new level, or a new change set up. So let's go into how this actually works, because that's probably what you guys came to this video for. Let's start with the bridge. So the bridge has a line, and how do we go from a line to a bridge? Well, the first thing we need to know is what are the steps? So the first thing we're going to do is we're going to make sure we can add a little bit of a sag. So right now we've got 2 points, and that's not enough. So we're going to add 2 points, and then we're going to say for each curve you input, we're going to drag the middle 2 down. And after that, we're going to convert it to a smooth curve, we're going to add some extra points. We're going to add a normal for the direction and an up direction. And then we're going to say, I'm going to copy a line to these points. Now you might imagine, why did I copy a line and not just, you know, the planks directly? We'll do that later, right here. But the first thing we want to do is we want to try and figure out where our ropes are going to be. So what we're going to do is we've got all these primitives, and there's a really cool node in Houdini that's called skin, and it connects every primitive, you know, primitive 0, point 0 to primitive 1, point 0, primitive 2, point 0, and so we've got these little sweeping lines here. So if we do this twice, we can basically get, we can basically move those up, and we've got our ropes. Our ropes are now hanging here. Now, we also want to find the location of our pillars. So what we're going to do is we're going to take the very first and the last primitive. This is signified by primitive 0 and primitive n. It's the number of primitives. So that's always the last one. And then we're going to place our little pillars right there. So now when we combine these two things, I'm just going to disconnect the other options, we've got kind of the starting of a bridge, but we definitely need to have some more things. So how do we add the planks? Well, the first thing we had was we've got all these positions, and on each of these positions we can place a board. So what we're going to do is we're going to take the direction that we already have calculated, we're going to add a little bit of randomization to it, we're going to move it up a little bit so we're not sticking through the rope, and then we can place some points. Now we could turn off the randomization of the scale and the direction, but it just makes for a very uniform looking bridge. So we add a little bit of scale randomness, we add a little bit of direction randomness, just to make sure it looks a little bit more interesting. After we do that, we add a remesh. Really what you typically do is you would just make board meshes for each board and you know, choose a random mesh. But in this case I figured this was a little bit easier to set up, and I wanted this file to be easy to understand rather than you know, as good looking as possible. So now what we've got is, it's pretty good, but we really want these vertical ropes to hang here. So what we're going to do is we're going to take what we have here, and we're going to split it into just the ropes on either side. It's a little hard to see, but you can see I've got the ropes on this side now, and what we're going to do is we're going to do the same thing with the skin node. We're going to connect point 0 of primitive 0 to point 1 of primitive 0, etc., etc. And so what we're going to get is we're going to get these cool vertical connections. We do the same thing on the other side. We merge that data in. We expand that shape a little bit. We add that in, and voila, we have a bridge. And the cool thing to remember is that, you know, this just came from a line. You know, there was no secret trickery here. We can change these curves whenever we want. We can have as many of them as we want. All pretty easy to do. Now you could be clever and basically say, well, I want the width to be controlled by an attribute at the top, so it controls the size of this box, and it also controls the width of this line. So if you increase the width of this line, for example, you can, you know, make the bridge wider. You can do all kinds of cool things, but for now, this is good enough. Now, on to the main event. How did we take this shape and make it into a terrain? Well, there's a number of ways to do this, and this is not necessarily the best way, but it's an easy way to understand this, and it covers a bunch of different ways of scattering things on top of a terrain as well. So, if we double click this guy, we're going to go in, and you can see I've added some notes here as best I can. And the first thing we're going to do is we're going to make sure that the polygons face up. And so how we do this is we basically assign it a normal, we split based upon whether the normal faces up or down, and we flip the ones that are facing down, just to make sure that we always, when we extrude this shape, it'll always extrude the right direction, which is down. We're going to remesh, which means we're adding a bunch of polygons in the middle here, And you can change the level of the amount of polygons in here if you wanted. You can have less or more of them. I figured this number was reasonable, but again, we can optimize this later, but for now I just tried to keep it simple. Then what we're doing is we're adding some noise. So this just adds some noise to the position. If you double click this guy, you're going to go inside, but first I want you to just look at all these numbers here, and what you can do is you can change the amount of offset like that, and we can change sort of the frequency. Is it like a very smooth sort of frequency, or is it very high frequency noise? You can play around with these numbers the way you want. You can make it all kinds of noises. But basically what this just does is we take the position, we feed it into a noise function, and then we've exposed, by middle mouse button clicking here, we can click promote parameter. We can expose these parameters. I'm multiplying the Y component so that we can control the amount of up and down noise from the side to side noise, and then we just add it to the position. Now there's fancier ways of integrating those two values, but really we're just adding two values together. Some noise and the current position, and that's going to noise things up. Now then we're going to do a little bit of smoothing. I'm going to make this a little rougher. We're just going to do a little bit of smoothing to get rid of some of the the bad qualities of the noise. And now we're going to get into the thicker part. So first thing I do is I just want to keep the edge. Why do I want to keep the edge? Is because I want to extrude the edge down, and we're also going to use it to place things on the edges. Now we're going to get to that in a second, but first thing we're going to do is we're going to try and make some walls. Now here we see a for each SOP, and a for each SOP basically says for every primitive or every primitive with a certain attribute, in this case it's just for every primitive, we're going to extrude down and do some things. Now you can also see that I've assigned a color, and so basically what I've done here is we take a primitive, we're going to give the original a color, we're going to give the other one, we're going to move it down, now we're going to smooth it out a little bit, we're going to merge those two, and we're going to use our friend the skin node again, this time not set to columns but to quadrilaterals, and we get a lot of interesting information there. We basically have a shape. Now the important thing to realize is that this shape matches exactly to the edge right here, because we've just extruded it down basically. Now, after doing all these guys, if we were to combine these two, I just press tab to add a new node, and then I type merge to get this node. We get this, and this is sort of starting to look like what we were trying to do before, but it could definitely be better. So what we're going to do is we're going to take the sides and we're going to use the remesh node again. And what our remesh node is going to do, like the previous time, it's just going to add a lot of polygons, and we've got a lot more points to work with to make sure that we can add some detail. So this node always takes a little while to cook, but what we're going to do with those points is we're going to offset and move them around. So in this case, we've got another noise function, very similar to what we had before, and it's just going to move these walls a little bit. But there's a trick in here. Remember I added the black color at the top and the white color at the bottom. We're going to use that. We're going to use that to control how much noise gets applied. Because if we were to noise everything, so if I turn this off, this color, if I were to noise up everything, what's going to happen is that the top also gets moved, which means it won't fit with the ground that we had defined earlier. So we basically need a soft fall off that is going to make sure that when we put these two things together, things are going to line up correctly. So as you can see right here, right now, this has become a hot mess. We can't use this anymore. So how does this work? Well, you have to think of colors as a value. basically colors are just numbers. And in this case, black is 0 and white is 1. So what we can do is we can calculate a noise, which is basically an offset, and then with that noise, we can multiply the value of the noise times the color. So that's literally what we're doing right here. So we're adding noise. We're doing some stuff here. Basically, I'm just removing the y component because I only want to offset side to side, not up and down. And then what we do is we just multiply these values times CD. CD is color diffuse. And then we add it to the positions, and presto, there we are. And now if we look at this result, everything matches up nicely. And that looks pretty good, right? Now, of course, this works well, but it's a little boring, it's a little empty. So what we want to do is we want to just add some stuff on top. And really what this comes down to is lots of layering. So how does this work? Well, you can see I've got tiles, I've got these sort of, I don't know, pillar kind of objects and rocks. Again, I didn't try and make anything beautiful. It's more about showing you how it works. So if we go into this tile system, there is a node that again makes some noise, and we select a color from that noise. So in this case we select, we set the color to be a vector of cd.x, so that's the first component, so that's the red channel. A vector is described as xyz, a color is described as RGB, so the x component of a color is red, y is green, g, and z is blue. And then we can basically scatter based upon where the color is most prevalent, and then we can just copy the simple model, which is, I don't know, just a very simple shape onto these points. And here we go. We have the ability to add some stuff, and we can change where these guys go. We can just change the noise, and you can do fancier stuff too. Maybe you want more tiles on the edge or less tiles on the edge. You can calculate the distance from the edge and do things like that. In this case, I didn't want to go too far. These two are basically the same, and when we add this all together, we're going to get this result. We merge that in with everything else, and here we go. We've got some pretty interesting stuff lying on the ground. Obviously this can be improved, but we wanted to keep it simple. However, that's not quite enough. We wanted to have some logic on the sides. So I took our original curve here, and I cut it into little sections, and I assign again a little color to it, and that color we're going to basically delete based upon that color. I'm going to calculate the direction again, and kind of like the fences we had before, I'm just going to add some stuff in here. So what that's going to do is we've got some little fences around the side here, just like someone's tried to build a guardrail. Now what I didn't do relative to the fence is I didn't constrain the up direction and the normal to be exactly flat. And that just gives us a little bit of this sort of natural overhanging and collapsed look that in this case I like. And you could add additional randomization if you want. Last thing we want to add is I wanted to just add some random rocks. And in this case I built a little tiny rock generator. And so what you can do is it just loops over a bunch of points we scatter on the sides of the walls, and then it generates a unique rock for each of them, and it just places them all. So we get to something like this. Now, the only thing we need to do is we just need to clean up our attributes, and that's pretty good. Pretty happy with how that looks. And then we've got our output node, and we can basically merge that in with our super long, in this case, bridge. And there you go. You have an entire level. Now, you can export this into Unreal. Typically what we would do is we would make sure that all these guys that I copied here, we don't just send them through as geometry, we would send them through as instances. So you would make some sort of an interface file towards your engine. But for now, I figured this would be descriptive enough. And if we were to try and render this, go into our camera, and I'm just going to grab our camera. So I'm just going to say select camera. Just going to rotate this view a little bit. Oop, wrong button. Select camera. Just going to rotate that view a little bit. We can just go to the render view. We can hit render, and that's going to give us more or less the look like you would see in the game. So after you've built your lighting, it's going to look something like this. Obviously, we don't have any materials on here or any other fancy things that can make this look way, way, way better. But the ideas stay the same, and really we can come up with any type of logic that defines where things are scattered or how things get built. But these are really the building blocks that allow you to build these kinds of environments. So hopefully this was interesting to you. Feel free to look around in this file and play around with it, break it, change it, add things you like. If you have any questions, feel free to email me. I'd be happy to answer some of your questions wherever I have time. But yeah, I hope that was interesting. Yeah, good luck with it, and enjoy Houdini. Bye.